6.2 is properties of power series. Okay. From the geometric series, we can derive one plus x squared plus x cubed plus x to the nth plus dot dot dot. Okay, this is equal to the summation as n equals 0 to infinity of 1 over x, or sorry, is just xn, not 1 over x to the nth. Okay, this has a sum, okay, a sum of 1 over 1 minus x if x is the common ratio, where the absolute value of x is less than 1. Okay, so if x is if x is a fraction less than 1, then this thing converges to 1 over 1 minus x. Okay, it actually equals that. Okay, we could say this equals 1 over 1 minus x. We're going to use this idea, okay, that 1 over 1 minus x is equal to 1 plus x squared plus x cubed plus dot 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 plus x to the nth plus dot dot dot, which equals the summation of n equals 0 to infinity of x to the nth when the domain of x is between 1 and negative 1. Okay? This does not work when x is 1 or when x is negative 1. Okay? It only works for any value between 1 and negative 1. The endpoints, they diverge. Okay? So let's try to express different functions of x. We can call this an f of x. Okay, f of x is equal to 1 over 1 minus x, and we can express that as a power series. So this thing, 1 over 1 minus x, can be expressed as a power series. Okay. Okay, so let's try to figure out another function of x that we can express as a power series. So we're going to say express, I should say, express 1 over 1 plus x squared as a power series. Okay. So let's express that as a power series. So what would this look like? Well, 1 over 1 minus negative x squared is the same as 1 over 1 plus x squared. I just put a double negative there. Okay, negative, negative. So 1 minus x squared. Okay, I'm going to put this little negative x squared in parentheses. The negative is not being squared, so keep that in mind. Okay, but what do I know about this? This is going to be equal to 1 plus, well, here I'm going to replace x with a negative x squared. This is negative x squared plus negative x squared plus negative x squared cubed plus negative x squared to the fourth plus dot, dot, dot. This becomes negative x squared to the nth power plus dot, dot, dot. Okay, goes on forever. Let's see what happens when we multiply this out. This becomes 1 minus x squared. Okay? Then we have a negative x squared squared. That's plus x to the fourth, because the negative now is being squared. This becomes minus x to the sixth, because this is a negative to the third power, which is negative. This is plus x to the eighth plus dot, 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 plus. This is negative 1 to the nth power times x to the 2nth power plus dot, dot, dot. Okay. And so this is an alternating series. This tells me that 1 over 1 plus x squared is equal to the summation of n equals 0 to infinity of negative 1 to the nth power times x to the 2nth power. And that is my function expressed as a power series. And so we can start expressing functions now as power series. Kind of cool. Okay. Let's talk about differentiation and integration. Okay, differentiation and integration of power series. Okay, differentiation and integration of power series. Okay, theorem. Okay, if the power series summation Cn x minus a to the nth power has a radius of convergence r greater than 0, so it converges for some r. Okay. Okay, then the function f defined by f of x equals c naught plus c1 x minus a plus c2 x minus a squared plus dot, 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 plus cn x minus a to the nth, okay, equals the summation as n equals 0 to infinity of cn x to the nth. Oh, sorry, this should be cn x minus a to the nth. Okay, if we have a function defined by that, okay, okay, if this thing is differentiable, and therefore continuous, okay, because it can't be differentiable if it's not continuous, on the interval a minus r, a plus r, okay, if it's differentiable and continuous on that interval, then the following are true. Okay, 1, f prime of x is equal to C1 plus 2 C2x minus a plus 3 C2, or sorry, C3 x minus a squared plus 4C, sorry, plus, yeah, 4C4 times x minus a cubed plus dot, dot. Okay, and this is going to be equal to the summation as n equals 0 to infinity of n times x minus a to the n minus 1 power. Okay, so basically we're just going to take the derivative term by term by term by term, and it just ends up being this nice little power series. Okay, 2, we can also integrate term by term. The integral of f of x dx is going to give me c. This c is a constant. Okay, because when we integrate, we get a constant. Remember, plus c. Okay, that's my plus c. Okay, plus a constant. Okay, plus c naught x minus a plus c1 over 2 x minus a squared plus c2 over 3 times x minus a cubed plus dot, dot, dot. This equals the summation n equals 0 to infinity of Cn over n plus 1 times x minus a to the n plus 1. Okay. Oh, you know what? I left this off. I'm sorry. This should be c. There should be a c. It says n times c. What? C n minus 1, I want to say. No, c n plus 1. Yes, n times c. I can't do it. It's still c n times, yes, times x minus a to the n minus 1. I believe. Let me think about that for a second. No, I need this to be a 1. I'm sorry. That's a 1. That's a 1 now. Because we're starting at C1. Okay, and that is n minus 1. Yes, that works. And then we go to 2, C2. Yes, okay, that's perfect. Okay, so for the derivative, we get this formula. Okay, and the integral, we get this formula. Right? Okay. Okay, let's do an example. Okay, number 2. Okay, find the power series express 1 over 1 minus x squared as a power series. Let's express it as a power series. Okay, this will converge, okay, Okay, let's look at the original series. 1 minus x, right? Okay, 1 over 1 minus x is equal to 1 plus x squared plus dot 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 plus x to the nth plus dot dot dot. This only converges when we have the absolute value of x is less than 1. That means that the radius of convergence is 1. Okay, on this. Okay, for this series. But now they're saying, well, we want to square this whole series. That would be like taking this whole thing and squaring it. Okay, but that, yeah, that's not going to work out too well, because we've got an infinite times an infinite. It's going to be hard to deal with. I will show you how to deal with something like that in the next session. But the easier thing to do here is to notice that the derivative of 1 over 1 minus x is actually, okay, 1 over 1 minus x squared. It's actually 1 over 1 minus x. That's the derivative. Okay, now why is that? Okay, well, if we took the derivative of this thing, this would be d dx of, let's put in some what is I'm trying to say, just in between. Okay, let's take some in between steps here. Okay, and this is going to be d dx of 1 minus x to the negative first power. Let's take the derivative of that. Let's use the chain rule. This is d dx of negative 1 to 1 minus x to the negative 2 power times the derivative of the inside, which is negative 1. So this thing becomes d dx of, the negative 1's cancel, and I'm just left with, I'm sorry, we took the derivative already. We don't need the d dx anymore. This equals that. Okay, and this is going to be equal to 1 minus x to the negative 2 power, which is 1 over 1 minus x squared. So we know the derivative of this power series, 1 over 1 minus x, is the function that I'm looking for. Okay. So I'm going to say that the derivative of 1 over 1 minus x, I'm just going to do that term by term. Okay, the derivative of 1 is 0. The derivative of x is 1. The derivative of x squared is 2x. The derivative of x cubed is 3x squared. Derivative is, we're just going to keep going, 4x cubed plus dot dot dot. This is going to be plus n times x to the n minus 1th term plus dot dot dot. Okay, so this is equal to 1 plus 2x plus 3x squared plus 4x cubed plus dot 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 plus n to the x to the n minus 1. Okay. If we look at this, if we start with the series n equals 1 to infinity, okay, what are we going to have here? Well, we're going to have 1 times x to the 0, that's just a 1. Then we're going to have 2, right? So this should just be n, x to the n minus 1. Okay, is that power series. Now you might see it look like this, okay, as, you know, what is 1 over 1 minus x squared. You might see the power series look like that. You also might see it being backed out by one term. Okay, but we would be like, well, what's the 0? You know, what's could we change this to n equals 0? Okay, if we want to change this to n equals 0, sure, I just have to add 1 here, and I have to add 1 here. Okay, so we could also rewrite this as 1 minus x squared is equal to this summation n equals 0. We generally like to start power series with 0, but if I add 1 there and I add 1 here, okay, just to make sure that my index gets increased by 1, even though I'm starting at 0, I would want to do n plus 1 times x to the nth power. Okay, and you might see in some books that it looks like that. Okay, where we're actually starting, okay, our power series at 0. Okay. Okay, the radius of convergence on this is r equals 1. Okay, and the interval of convergence is going to be the absolute value. It's going to be negative 1 to 1. Okay, let's do another example here. Okay, number 3. Find the power series for the natural log of 1 plus x and its radius of convergence. Okay, find the power series for natural log of 1 plus x and its radius of convergence. Okay, so we need to change this into some sort of familiar power series. Okay, so I'd like to get this to be equal to 1 over 1 plus x. Okay. Well, how could I do that? Is there any function that would change 1 over 1 plus x into the natural log of 1 plus x? Any function that would change the integral of 1 over 1 plus x into the natural log? Yeah, it's the integral, right? Okay. So if we integrate, okay, then that is going to be this plus c. Okay, you could do a u sub on this if you really wanted to, 1 plus x, but it's du is equal to dx, right? So this is just the integral of 1 over u, okay, which is just the natural log of u plus c, but what was u? Natural log of 1 plus x. Okay, natural log of 1 plus x plus c, right? Okay, again, let me put the absolute value bars in and then explain why we don't need them. Okay, so we have the natural log of 1 plus c, or 1 plus x plus c. Now, why don't we need the absolute value bars? Any ideas? Well, if we look at the power series 1 plus x, this is 1 over 1 minus negative x, okay? Which tells me that this thing here, that which I am subtracting off, negative x, the radius of convergence is the absolute value of x is less than 1. Okay, that's the radius of convergence for this thing. Okay, because the original 1 over 1 minus x, the radius the radius of convergence for that, okay, is absolute value of x minus 1. I'm just replacing that with a negative x this time. Well, the absolute value of negative x is just absolute value of x. I could pull that a negative 1 out. And then we get 1 times the absolute value of x, which is just the absolute value of x, right? Okay, so what does this tell me? That tells me that x is already restricted from negative 1 to 1. That's what it tells me. The radius of convergence of this thing, r, is equal to 1. That the radius of convergence is already 1. So if the smallest value that I can take on here is some negative fraction, isn't 1 minus a negative fraction still going to be positive? Does that make sense? If 1 plus some negative fraction, isn't that going to still be a positive number? Okay, so this stays positive. Because of the domain. Okay, so what is this telling me? It's telling me that if I were to integrate 1 over 1 plus x dx, I'll pick up the dx up there, that's okay, dx, okay, then what I should end out with is my natural log of 1 plus x, okay, in parentheses. Okay, so let's do this as a power series. Let's say, okay, well, 1 over 1 minus negative x is going to be, okay, well, let's do the 1 minus x first. This thing is going to be 1 plus x squared plus x cubed plus x to the 4th plus dot 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 plus x to the nth plus dot dot dot. When we have a radius of convergence of 1, 1 over 1 minus negative x, this is going to be 1 plus negative x squared plus negative x cubed plus negative x to the 4th plus dot 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 plus negative x to the nth power, when the radius of convergence is absolute value negative x, which is just the absolute value of x. Okay, it's the same radius of convergence. R is equal to 1. Okay, so we have 1 over 1 plus x is equal to, now let's look at this. This is 1 minus x plus x squared minus x cubed plus x to the 4th minus dot 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 plus, I'm going to factor out the negative sign here. This is negative 1 to the nth, x to the nth. Okay, and so we get an alternating series here. Okay, and what I'm going to do is I'm going to integrate this, okay, term by term. Okay, let's integrate this term by term. Okay, so this is going to be the integral. Let's integrate this now. Dx. Integrate. This is going to get me the natural log of the absolute value of 1 plus x plus c is equal to, I've got to add the plus c here. That's my constant. Okay, plus c. Okay, now let's integrate this term by term. The integral of x of 1, x. The integral of negative x is negative x squared over 2. Okay, the integral of x squared is 1/3 x cubed. Maybe I'll just do this as one hand. X squared. 1/3 x cubed. Okay, and then minus 1/4 x to the 4th. Okay, and we can keep going, plus like that forever. okay, okay, plus 1, this is 1/5, right? The next one will be 1/5, x to the 5th plus, okay, so now, what are these guys going to be? Well, the -1 to the nth power, that's just a constant, so that stays out in front when I integrate. Okay, that's just a constant. So it's still going to alternate. Okay, it's just, okay, now what's x to the n going to become? It's going to become 1 over n plus 1, x to the n plus 1, right? Okay, plus dot, dot, dot. Okay. Okay, now what's the constant here? We have to say, well, can we solve for the constant? Okay, so the constant, yes, we can. The constant, we're going to let x be 0 to solve for c. So when I let x be 0, what's the natural log, okay, of 1 plus 0? Okay, on this side. Okay, the natural log of 1 plus 0, okay, is 0. It is 0. Okay, and so so the constant here is just going to be 0. C is equal to 0. Okay, we're just going to let the constant be 0, because when I plug in, when x is 0, I get everything plus a constant. But on the other side, we get natural log of 1 plus x. Okay, we've already described why this is the natural log of 1 plus x in parentheses. We got rid of the absolute value bars because of the radius of convergence. Okay, due to this being a power series. Okay, so, okay, we're going to say the natural log of 1 plus x is equal to, the constant is gone. We now have this pattern, x minus 1/2 x. So we know that this is going to be the summation. I'll start at n equals 0. Okay, and try to build this. Okay, so n equals 0 to infinity of -1 to the nth power. Does that work? My first term is positive. Yes, that works. Okay, and then this is going to be x to the n plus 1 all over n plus 1 power. Yes, this does work. Okay, and so this will give me every term that I'm looking for. Okay, with the radius of convergence of 1. This is going to be r is equal to 1. Okay, okay, let's do one last one here. Okay. Let's do number 4. Okay, find the power series for f of x equals inverse tangent of x. Okay, f of x equals inverse tangent of x. Okay, so we want to know, can we relate the inverse tangent to some sort of power series? Well, how is inverse tangent related to this? If I put up 1 over x squared plus 1, how do we relate this to inverse tangent? How are those two related?
Integration, right? Or
Again?
integration?
Um,
Or
wait, which direction?
If we integrated the inverse tangent, right?
Yeah, if we integrate the inverse tangent, then we get the 1 over x squared plus 1, right?
Right.
If we differentiate the 1 over x squared plus 1, we get the inverse tangent. Does that make sense?
I see.
Okay. So, we're going to say that the integral, okay, of, okay, so if we differentiate the inverse tangent, yeah, you're right. Sorry, I was backwards. If we differentiate inverse tangent, we get 1 over x squared plus 1. If we integrate, we get the inverse tangent. So we're going to say that the inverse tangent of x is equal to the integral of 1 over x squared plus 1, right? So the inverse tangent of x is equal to the integral of 1 over 1 plus x squared. Okay, but how can I rewrite 1 over 1 plus x squared? I could rewrite that as 1 over 1 minus a negative x squared. Okay? And we already saw what this was. I think this was example 1, right? So in example 1, we did a lot of the heavy lifting here, because in example 1, we said that this was equal to 1 minus x squared plus x to the 4th minus x to the 6th plus dot, dot, dot. Okay, and so if we integrate this term by term, what we're going to get, okay, we're going to get, okay, x minus 1/3 x cubed, right? Okay, let's put the plus c here first. C plus x inverse tangent of x is equal to c plus x minus 1/3 x cubed plus 1/5 x to the 5th. Okay, so how did we get this? Just see example 1. Okay, x fifth minus 1/7 x to the 7th. Okay, plus dot, dot, dot. Okay, so how would I get a power series for this? Okay, well, first let's deal with the constant. What's the constant going to be? If I let x be 0, everything goes to 0. Okay, so all of that goes to 0 except c. But what is the inverse tangent of 0? Oh, the
0.
angle whose tangent is 0 is 0. So 0 is equal to the constant. So that goes away. So we want the inverse tangent of x to equal x minus 1/3 x cubed plus 1/5 x to the 5th minus 1/7 x to the 7th. Okay, so now let's come up with some sort of series here that works. I'm going to think of this as a 1 over 1 x to the 1st. I think that's going to help me. I want to start n equals 0. Let's start with n equals 0 to infinity. Okay, so this is going to become negative 1 to the nth because it's going to alternate. But then what am I going up by? I'm going up by odd numbers. So how can I get odd numbers to generate? Well, there are two things that will generate odd numbers. We call these odd number generators. Okay, and it's either 2n plus 1 or 2n minus 1. So which one do we want to choose here?
Two
If
n
we
minus
start with
1.
1, we would want to use 2n minus 1. If we start with 0, we want to use 2n plus 1. Okay, so this is going to give me x, the 2n plus 1, all over 2n plus 1. And that is the power series for inverse tangent of x. Okay, now what's the radius of convergence on this? Let's look at the radius of convergence. Okay, before when we had 1 over 1 minus x, the radius of convergence was absolute value of x is less than 1. Okay, so r was equal to 1. But here we have 1 minus negative x squared. No, not, it's a negative of an x squared. Negative of an x squared. So what's the radius of convergence there? It's negative x squared. Okay, let's put that inside the absolute value. Okay, this I could break off the negative. This is negative, absolute value of negative 1, absolute value of x squared is less than 1. Okay. So the absolute value of negative 1 is just 1, so that goes away. Okay, the x squared is the same as taking the absolute value of x squared. But what is, isn't x squared always positive? I mean, let's think about what x could be. Okay, x could be a negative, x could be a positive, right? So if x is a negative, that gets squared, and then we take the absolute value. That's always positive. Everything's going to be positive here. Okay, no, regardless of what x is, I'm always going to get a positive value. Okay, so what could x possibly have been? Okay, well, x could possibly have been the absolute value of x squared. We could pull the squared outside. We could then take the square root of both sides. Okay. So then we could say the absolute value of x is less than the square root of 1. We could put a plus or minus 1, but only one of these makes sense. Okay, how could you have an absolute value less than a negative number? It doesn't make sense. So the negative doesn't make sense. Okay, so this is absolute value of x is less than 1. Okay, and so absolute value of x, that's just r equals 1. Okay, so the radius of convergence, okay, is r equals 1. Okay, for that guy. Okay, and that is 6.2.